Hey mathematicians, here are your notes for 12.4, talking about dividing rational expressions. So no bell work today, as you can see, but the goal is to be able to divide rational expressions. We've already talked about what those are. So consider this, a 14-ounce box of cereal costs $3.92. If a 16-ounce box of the same cereal costs the same per ounce, how much does the 16-ounce box cost? So what we're gonna have to start by doing is figuring out if it's $3.92 for a 14-ounce box, what would it be for a 1-ounce box? So we're gonna take that $3.92 and divide it by 14. We'll go ahead and throw this in a calculator. $3.92 divided by 14 is 28 cents. So if it's 28 cents per 1 ounce, then we would obviously have to multiply that by 16 to get a 16-ounce box. Again, bring it back, times 16, you get $4.48. $4.48. But it would be really nice if there was a way to put all of that into fewer steps and be more efficient. That's what we're going to learn today. So the problem above is known as dimensional analysis. Dimension means part, analysis means to look at certain parts. But before we jump into this further, we need to understand that dividing rational expressions follows the same pattern as dividing fractions. So if you don't remember what that looks like, when we have one fraction divided by another fraction, we're going to use the keep, change, flip method or the invert and multiply method, whatever works best for you. So we're going to keep the first fraction, keep it the same way it is. We're going to change the sign of multiplication, division to multiplication, and then we're going to flip the second fraction. So instead of C divided by D, we're going to do D divided by C, and then just multiply across. So A times D over B times C, and then we're going to obviously simplify if at all possible. We can simplify first, or we can multiply and then simplify. It's up to you and what is easier. For this first one, I'm going to show the multiply then simplify. For the next one, I'll show the simplify then multiply so that we can see both methods. So these are both monomials. Monomial divided by monomial, divided by monomial, divided by monomial. So I'm going to use that method that I just showed you up here. Let's go ahead and keep the first fraction just as it is. We're not going to do any simplifying. We're going to change the sign to multiplication. You can put a little dot if you prefer and you don't like the X. And then we're going to flip the second fraction. So the 10ab goes to the top, the c squared d squared goes to the bottom. Now we're going to multiply. 12 times 10 is 120. C squared, D squared, A and B. We can't really simplify those at all because they're different variables. So we're just going to put them all back together. Now let's go ahead and do the same thing with the bottom. 5 isn't multiplied by anything, so we leave it. And then there is C squared, D squared, A squared, B squared. But we can't just leave that. We have to simplify it, obviously, after we multiply. So let's go ahead and do that now. I'm going to go ahead and set up my parenthesis. 125 over 5, let's simplify that using our little ABC button. Should look like that. When I do that, I get that it's just 24 over 1. If it doesn't end up as a fraction, it's just over 1. I'm not going to write the 1 on the bottom. We know it's there. C squared divided by C squared. Let's go ahead and grab a different color for this. Anything divided by itself, as long as it's got the exact same exponent, is just a big fancy 1. So that reduces to 1 and we don't need to write it again. D over D squared, that would be D to the negative 1 on top, or just D on bottom. A over A squared, same thing, we just end up with 1 on bottom. And B over B squared becomes B on bottom. So 24 over DAB would be our final answer. However, Just like we learned in the last unit, there's something we need to be aware of with these fractions. So let's go ahead and find those excluded values. Remember, you're not finding the excluded value of what you just simplified, you are finding of the original problem. And that is why in the last video I said do it first. You can see that I obviously forget this pretty often, so don't forget to do it yourself. So let's go ahead and check. The only problem I would see in this fraction in the denominator would be if a or b was 0. So a or b cannot equal 0. In the second fraction, yes, I do have to check both. A and b can also not be 0. So there's no real concerns I have for that one. All right, so like I said before, this one was a multiply then simplify method. This one we're gonna do a simplify then multiply. And that doesn't mean we don't have to maybe simplify after we've multiplied, it just cuts down what we have to do. So let's go ahead and simplify these. I'm going to break these down, I'm going to factor them first, just like we did in the last video. So top one, x and x, what multiplies to 27 and adds to 6? I think positive 9 and negative 3 will do it. On the bottom, we get x and x, 18, positive 9, positive 2. And then I'm also going to do the step of multiplying, but I'm going to simplify as I do that. You'll see what that means. So I'm going to multiply. I'm going to factor the denominator on top and just bring the numerator to the bottom of the fraction. So what multiplies to negative 2 and adds to positive 1? Positive 2 and negative 1 will do that. All right. And the cool thing is if we simplify like this, since we know we're just multiplying across, what I can do is a little shortcut, and I can just extend this line so it's all one big fraction. Now there's a giant hole in the middle here, but we can just do a multiplication dot in there. Now let's simplify across. Again, I'll have to go back and check excluded values, but excluded values for the denominator of this one would be x equals, or does not equal, negative 2 and negative 9. Remember, I put the denominator up here. The excluded values for this would be negative 2, which we already have, but also positive 1. So there's a lot of working parts going on right now. Once we've got excluded values, let's just find those ones I was talking about. Let's reduce. So x plus 9 over x plus 9, that's just a big fancy 1 hidden in there as x plus 9. We actually have the same thing going on with the x minus 3. I can't really draw a 1 between those, but you get those are reducing also to 1. And we even have an x plus 2 and an x plus 2 that reduce to 1. Meaning once we have reduced all of those pieces, we are actually just left with an answer of x minus 1 on top with excluded values of negative 9, negative 2, and positive 1. Isn't that awesome how such a awful and gross looking original problem can come to a pretty simple and nice final answer? Let's look at a couple more. This one, I promise I'll be better. Let's find those excluded values first, not after. So in this case, a cannot be, well, pretty simple on that second term, can't be 0 there. And then over here, we also find that a can't be 0, but b can also not be 0. We've got monomials divided by monomials, so there's not really a need to factor like we did in this problem. Instead, we're just going to use our keep, change, flip. So 12ab, keep the first. I'm going to multiply, then simplify. Like I said before, change the sign, and then flip the second goes to a over b. Use your little shortcut of just extending, and then let's go ahead and simplify. So a times a is a squared, and a squared divided by a is just going to reduce to 1, just like it did in the last problem. And we've got b's all over the place. I could put b over b squared. We'd end up with b negative 1 on top. Instead, I'm just going to reduce these right away to 1. so that my final answer, when I get rid of all of those slashes that I've reduced, I now get 12 on top over b on bottom, where my excluded values are a and b not equal to 0. Just like that. All right, if you're feeling confident about polynomials and monomials, go ahead and try those next two. Pause the video and try those on your own, and come on back and we'll do them together. If you're not quite ready, pause the video and we'll be back in just a minute. All right. Hopefully you had a chance to try those on your own. Again, if you're not comfortable, that's okay. Let's go through them together. I see a poly over a mono, so I'm going to go ahead and factor that. Anytime I see big polynomials, I just like to deal with them right away. Multiplies to positive 6, adds to negative 5. Make those negative over 5. I'm going to keep the fraction, change the sign, flip the second, so 15 over x minus 3. Notice with this one, we didn't have to find excluded values first because there's nothing that could make the bottom 0 because it's already 5 and 15. I didn't even have to check for excluded values there. This one, when I simplify, 15 divided by 5 is going to reduce to 3 over 1. I'm going to do that this way. Some of you like to see this. So 3 over 1 reduces. And then x minus 3 divided by x minus 3 reduces into a big old 1. Notice I always write a 1 to show you that it reduces. They're not canceling. They are reducing to 1, which we can then just not write anymore. So 3 on top times x minus 2. We're left with just a 1 on bottom, so I don't have to write it. And there's nothing that would make those denominators 0. So I don't have to write excluded values for this one. All right, you ready for the tough one? There's a lot going on with this, but I bet we can do it. All right, let's go ahead and find those excluded values. So I'm gonna have to factor that bottom one and as well as this one. So let's go ahead and put our fraction bars up. We know it's gonna be a multiply and flip. So keep the first. Let's factor this. A squared minus 9 is a difference of squares. A and A, 3 and 3. 1 gets subtraction, 1 gets addition. On the bottom, ooh, tough one. 2A and A to get a negative 7, but a positive 13. I'm pretty sure we're going to have to go positive 7 and negative 1. I'm going to flip, so the a plus 3 is going to come down. And this is also a difference of squares, so it's going to be 2a minus 1, 2a plus 1. Now let's find the excluded values in those two pieces. 2a minus 1 equals 0. I'm going to bring it up here. 2a minus 1 equals 0. Add the 1 over. 2a equals 1. Divide by 2. We get 1/2 is an excluded value. We also get negative 7 when we simplify this. And then we get the positive and the negative version, so we will also have to include negative 1/2 as an excluded value. All right, now let's simplify. Let's find those hidden ones. So a plus 3 divided by a plus 3, that's a hidden 1. We're going to reduce. 2a minus 1 and 2a minus 1, that's a hidden 1. We're going to reduce. I don't have anything on top and bottom that continues to match, so let's write out the final answer here. A minus 3 times 2a plus 1, all divided by a plus 7, where your excluded values are a equals negative 7, negative 1/2, and positive 1/2. You can see that these can be a little bit more challenging depending on what polynomial you have, but overall, the more challenging, the more rewarding. Let me know if you have any questions.